Okay, so we are going to be talking about the next section, which is 5.4, and it's called You Nailed It. You nailed it. Okay, so um, we've been talking about geometry, we've been talking about solids and revolving them around axes and stuff like that. And you should be comfortable with finding the volume of a cylinder for sure. A little bit on the cones, a little bit on the frustrums. But again, my suggestion to you definitely is if you work on your mind's eye of imagining what you're doing, it helps so much because then you can draw those things. So the better detailed you are about recognizing, like, like when you're drawing something in your mind's eye, then you can put it on paper. So keep that in mind. Sorry. All right, let's do this. Okay. So it says, so which one doesn't belong? I'm not going to make you guys do this, but whenever you're doing which one doesn't belong, I'm just going to tell you that all of them don't belong. The whole focus of this is always going to be why you think it doesn't belong, right? Okay, moving on. Okay, so it says apply geometric modeling to solve a real world problem. Real world problem just means that it's a word problem. Geometric modeling just means that you're going to be drawing it, writing an equation for it, graphing it. A model is just a representation of something. So those people that, walk down the catwalk and they're, modeling different clothes, they're they're called models because they are supposedly representing what a woman would look like or a man would look like in those clothes. Does that make sense? So a geometric model is no different. It's a representation of what you're trying to do. So it says, how can I use quantities, meaning numbers, and units, meaning gallons, minutes, numbers, to guide my computational thinking in a modeling context? This sounds really foreign. Don't worry. How can I model geometric context using properties of shapes and measurement? Okay, so properties of shapes we might have to spend a little time on, depending on how much you remember. So if you can right now start thinking about different shapes and what you know about them, it's going to help you. All right, so Tatiana is helping her father purchase supplies for a deck. For a deck he is building in their backyard. He wants the deck to be a rectangle with an area of 96 square feet, but he hasn't decided on the actual dimensions. The deck will be made of planks that are 8 feet long and half a foot wide. So kind of get that. Remember, I was telling you, the more you can imagine in your head, the better off like you will be able to do this. Okay. So imagine, so my brain is like, oh, they're making a deck. So my little brain goes, okay, let's create the deck. So the only thing I know about this deck right now is that he wants it to be 96 square feet, feet squared. Okay. And each of these planks, they say, I guess that was too long, but it's 8 by half. Yeah, it's 8 by half. Okay. So then this is what my brain, and then my brain is thinking about setting these up, right? Setting up planks along the way. So these planks will be attached to the framing joints. I don't know how to say this word, with 16D nails. They would like to design the deck to minimize the cost of the planks and the nails. Okay. So you're like, how's that going to help me? I don't know. So it says nails are sold by the pound at the local hardware store. I can't read this, so I'm going to go jump over here because it's too small. Wow, that's really small, guys. Can anybody read that? Just kidding. All right, put this back. Still really small, Miss Johnson. All right, here we go. Nails are sold at the by the pound at the hardware store. So Tatiana needs to figure out how many pounds of 16D nails to tell her father to buy. She has gathered the following information. Each decking plank costs $12. So this guy costs $12. So I'm going to write that down. Oh, I should probably write this on my thing. Give me a second. So I'm just going to continue reading, and they are only sold in 8-foot lengths. They're only sold in 8-foot lengths. So I'm going to just start highlighting some stuff. Where are we? Here we are. So each plank cost $12. They're only sold in 8-foot lengths. Tatiana's dad doesn't own a table saw, so he doesn't want to cut any planks. That's important, right? So that kind of tells you some of the dimensional stuff. Each plank requires 9 nails to attach it to the framing joists, one set of 3 nails at each end, and a set of 3 nails in the middle plank. So I'm just going to draw some drawings. I'm going to get rid of this stuff over here. So number one, you said this is going to be 96 square feet, right? Each plank is 8 by half, right? Each plank costs $12. Let's put that in this. Let's see. It requires 9 nails. Okay, so I'm going to go nail 1, 2, 3, 1, 2, 3, 1, 2, 3. That's what they described right there. So far, so good. So imagine this covering this whole thing. And remember, he's not cutting any of these in half. It says 16D nails are made of steel and have a density of 4.65 ounces per inches cubed. So don't know what that means. So I'm just going to highlight that and hopefully that'll come out later. But that is about the nails, right? So there are 16 ounces in a pound. Okay, I kind of knew that. And then it says the hardware store sells nails by the pound and 16D nails cost $8 per pound. Okay, so this is more about pounds. Is it possible to buy, and it is possible to buy a fraction of a pound. So over here, dad is not cutting any of these and he doesn't want to cut any of them, right? And they're only sold in full lengths. Tatiana has also found the following drawing of a cross section of a 16D nail. And she knows that she can use this drawing to help her find the volume of the nail, treating it as a solid of revolution. The scale on the y-axis is in inches. This is in inches. So number one, help Tatiana design a deck that will minimize the cost of materials. Show the work that supports your final design. Okay, so first of all, let's just talk about some stuff. Can you guys give me some possible dimensions of a 96 square foot deck? Can you start with that? Can you give me some possible dimensions? Dimensions means how long and how wide it is. How long and how wide it is. What are some possibilities here? Let's start there. Now I understand why it's called You Nailed It. Did you guys get that? Did you get it? Did you get it? Just kidding. I knew. I was just pretending. What are some possible, like, okay, someone says 8 by 12. So I can go 8 feet. Oops, that's not it. I can go 8 feet this way, 12 feet this way. Right? That's a possibility. If I go 12 feet then this person is imagining that we're just laying the planks down this way. Does everybody see that? Very good. And because we just did that one kind of like number talk, we can half and double things, right? So would it be possible for us, would Tatiana's dad be okay with halving this side, so 6 feet this way, and then this way going twice, so that would be 16 feet. Would Tatiana's dad be okay with 6 feet by 16 feet? Now think about it. What do you think? Yes or no? Tatiana's dad is the one who said, I don't want to cut anything. So lots of no's in the chat, and the answer is actually, yeah, it's okay. Right? So I can do 8 feet, right? Let me draw a different rectangle. Maybe down here? Sure. Since you said that I could do 8 feet by 12 feet, that means I could double my planks this way and that way. Like I have 2 sets of planks this way. So this would be 16 feet by 6 feet. So the answer here is yes. So it looks like this. I don't know. It looks like this more. Does that make sense? Yeah, 2 planks. Very good. Oh, he doesn't have to cut it if we lay it vertically. Yeah. Right. So here you guys are imagining your planks going this way, right? Kind of thing. Here I'm imagining the planks being double plank this way. Okay, what else could we do? Can we half it again? Could we go 3 feet by 32 feet? That was hurting my brain right now. Could we do 3 by 32? Could we do 3 by 32? So I'm just trying to get your brain to get in. Yeah. So because you could double it, right? All I'm doing is now, instead of having double plank here, now I have 4 planks in a row, right? So the answer here is yes. It looks the same. Sorry, Miss Johnson is bad at sizing things. So I should have made this really greater and make this, and then make this really skinny, but I didn't think about it. So imagine this being skinnier. It technically should be half of that. I now will fix it because I'm being bugged by it. So it would look something like this, right? Skinny. And you guys are like, Miss Johnson, would Tatiana's dad be okay? Tatiana's dad, his thing was, number 1, it's 96 square feet. Number 2, he's not cutting anything. And number 3, he wants it to be very cost efficient, right? Cost efficient. Okay. So I have a couple of options here. There could possibly be more. I don't know. Could I go twice this? Could I go half this and double that? Could I half this and double that for one more strategy? And the answer is, let's see, could I go 4 by 24? Can I go 4 by 24? Could I go 4 by 24? Yeah, you guys are like, yeah. As long as one of the lengths is divisible by 8, that's what you should be thinking. In this case, it's going to be 3 of them, right? As long as one of them is divisible by 8, then Tatiana's dad, she's fine. Or he's fine, rather. Okay, so I got that. So that is done. So our task is to, let's see, help Tatiana design a deck that will minimize the cost of the materials. Show the work that supports your final design. So minimizing the cost, what is the same in all of these? What is going to be the same in all of these? What is different in all of these, right? What is the same? Yeah, they're all 96 square feet, 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 right? So the next thing that I would possibly do is I would possibly now figure out how many planks, is that what they're called? Planks are in each of these designs. Because the more planks there are, kind of thing. The next thing I would also consider is the nails, right? Like how many nails? Like, does any of these, like, oh, how do I put this? Here's my question. Does the design matter on the nut? Wait, no. Does the design that I pick, is it going to be cheaper or more expensive for the planks? Not counting the nails. Ignore nails for now. Or is it all going to be the same? Does the design, either 4 by 24, 8 by 12, 16 by 6, or 32 by 3, are they all going to have the same number of planks? Are they all going to have the same number of planks? If you're not sure, check these two, right? So know that the number of planks is 8 by half. So how many, if this is how big it is, 8 by 12, how many planks is it going to have? How many planks is it going to have? Thanks. How many planks is it going to have? So go ahead and figure that part out. Okay, yeah, it's the same. Very good. So someone's like, Miss Johnson, it has the same area. Okay, so good. So it actually doesn't matter which area we've used. Good. So no matter what, the amount of money Tatiana's dad is spending on planks does not matter regardless of this. So then you should also know that it doesn't matter how the design is for nails either, right? Okay. So then we actually need to figure out how many nails, how much, it's actually how much nails she needs to buy, how many pounds of nails she needs to buy. So then we have to go into all this green stuff that I highlighted to help us figure that out. Okay. So number one, can you tell me how many nails I am going to use? How many nails am I going to use? Someone said in the chat, a lot of them, many of them. Yes. Can you give me a number? And know that, like, when you buy, I don't know, construction, I don't know if you've heard this term before, but in construction, they say things like measure twice, cut once. Measure twice, cut once. And the reason why you do that is because once you cut that piece of wood, you can't like glue it back together. Like, oh my bad, I wasn't supposed to cut it there. I was supposed to cut it there. So same thing in math. You want to measure and you want to make sure. Okay, so someone says in the chat, it's 216 nails, Miss Johnson. I'm going to do a little math with you just so that we are all on the same page. Here's my calculator. I don't know why it's so gigantic. There it is. So this is the way I would calculate it. In reality, this is 8 foot. So this is going to be 1. I'm going to use 1 plank this way and 24 planks this way, right? Because each plank is half a foot. So I'm laying them down that way. So it's 1 times 24. So that's 24 planks. Everybody okay with 24 planks? Yeah. So that's, if you want to think, that's the area of, that's 96 square feet covered by 24 planks laid side by side, right? And you can imagine, if you've ever seen like a wood floor, that each of those pieces of wood are laying flush next to each other. There's no gaps in there, right? So then, since I'm using 24 planks, each plank has to use 9 nails. And so they said times 9, that's where they get their 216. So I need 216 of these, but this hardware store does not sell it by the nail. They sell it by the pound. Because imagine how annoying that would be for you, customer, to count out 260 nails. That's annoying, right? Or the cashier who now has to recount 260 nails. Some of you are like, Miss Johnson, why don't they just sell them in packs of 100? I don't know. I actually don't know these things. So, but thanks for asking. Okay. So we got to figure out how much each of these nails weigh. So that's going to have to do with the volume of this. So your task right now is to figure out what's the volume of this. And you want a pretty accurate volume. You don't want to do you remember how I did this earlier? I said, hey, do you think this is a pretty good approximate of my volume if I revolve this rectangle? I can't get this right here. If I revolve this rectangle around the x-axis, right, this is not a good approximate. So this is not one of those cases. So right now, what I'd like you to do is cut up your shape so that you have shapes that you would like to revolve around your x-axis. Someone just put in the chat, they do sell them in packs, Miss Johnson. Thank you. Thank you. Tatiana's dad doesn't go to the store that you go to. I'm just teasing you. Okay. So I'm going to pause it really quick. I want your ideas. Think about how you would cut this up into shapes that you're familiar with. Are you, like, what shapes are you going to be using? So I'm going to pause the video really quick and give you time to think about this. Okay. So what you thought, and I saw a bunch of people's things. You saw, someone said, I see cylinder. So I see this red cylinder here. Do you guys all see my red cylinder here? Yeah, that's my red cylinder. And then I have this, I'm going to use just this blue highlighter for this other one. This guy here, I have this cylinder. Sorry, I colored a little bit outside the lines because my highlighter is very thick. So that's another cylinder. And then my last little cylinder is going to be this blue guy down at the bottom. And that's going to be a cone. So you're going to calculate this to find that. And we'll do it kind of on the quicker side just so that we can finish. So, or actually, I'll just explain it. So once you calculate this, right? Once you calculate your volume of this, the formula for this part here, calculating the cost of the deck, you now have to find out how much it weighs, because in order for us to figure this out, we have to go from volume to weight. And the formula for doing that is just volume times density, right? Because this is inches cubed. Do you guys all see this? So this, your volume answer is going to be inches cubed. And if you multiply inches cubed times inches cubed, you get ounces. Okay. So I'm going to do this. So I'm going to go cylinder. So this is going to be cylinder. I'm not going to draw it. So that's pi r squared h plus cylinder. Let's do this highlighted guy. I'm just drawing their 2D shapes. Plus pi r squared h. And then I go plus my cone, which was this guy right here, gives us our volume, pi r squared h. So, Ms. Johnson, you're just going to do that over and over again. Yeah. Any questions on this part really quick? Any questions on this? Because I'm just going to plug everything in and then ask my calculator to do it. Okay. So the hard part here is going to be you imagining what the R and the H are for each of these cases. So again, you're revolving it around your x-axis to make sure that you guys are getting the right thing. So here, this is going to be your radius, and this is going to be your height. This is your radius. This is your height. This is your radius, and this is your height. So you just got to collect those numbers here and then plug in as such. So I'm going to give you like 30 seconds to do that. I'm going to write out my formula with parentheses so you guys can see how I do this. Oops, that's not how I do it. So you're finding the radius and the height of each of these shapes while I write all this down. I love this. Okay, so here we go. So what's the radius of this first red rectangle? Oh, I used the wrong color. Yeah, so the radius of this one is going to be, wait, is that 0 and that's 0.4? I'm so confused right now. This is 0 and that's 0.4. So what would you guess that to be? It doesn't have to be perfect. Yeah, I got 0.3 too. Good job. I got 0.3. So this is going to be 0.3. So 0.3. So no, I'm just going to plug this into a calculator straight off. And how, what's the quote unquote height of this cylinder, also known as the length of this rectangle? Yeah, I got 0.12, 0.1. And then continuing on. So remember that you have to subtract off some stuff. So don't get confused by this. So this goes all the way to 3.2, my blue highlighter rectangle, right? Minus that 0.1. So this is 3.1 here. Versus the height of this, again, is going to be 0.1. So what? 3.1 goes here, 0.1 goes here. And then last but not least, the R again is 0.1. And your height for this one, what is that? 0.3? So from 2 to 4, that's 2.3. Okay, 0.3. So I'm going to plug this guy into my calculator because I can. You can't see Desmos. I can't see Desmos. Let's see. And I am going to use an approximation for pi. I'm actually going to use whatever Desmos has in it. So 0.3 quantity squared times 0.1 plus, I'm going to plug this whole thing in. Pi times 0.1 squared times 3.1 plus 1/3 of pi times 0.1 squared times 0.3. Okay. First thing that Ms. Johnson should probably do is make sure she plugged it in correctly. Pi 0.3 squared times 0.1 plus pi. So do you see pi r squared h? 1/3 pi r squared h. You should see that over and over again. So this is what? What does this represent? 0.1288. I'm going to go twice there. Yeah, this is the volume of a nail. So I'm going to write this as the volume of a nail. This is one nail. This is one nail's volume. Right? Okay, so let's continue. So you said, so, and by the way, this is inches cubed, right? So I'm going to multiply this 0.1288 times our density, which is up there 4. Oh man, I forgot something. Hold on. I'm rushing. Ounces over inches. Sorry. Try again. Inches cubed times our density. Our density is 4.65 ounces per inches cubed. Okay, ignore the numbers. I can multiply the numbers. What do you see happening here? What do you see happening here? And then we're done. Does anybody see it? What do you see happening? Yeah, the inches cubed goes away. Does everybody see that? Do you remember in stoichiometry, for those of you who took chem, units cancel too, right? So this is actually equal to 0.5989, approximately 0.5989. What is that? Well, Miss Johnson, because the inches cubed cancel, we have ounces left. Ounces of what? What does this represent? So we found the volume of a nail. We multiplied it by the density. This is how much one nail weighs. Everybody okay with that? But you all told me, how many nails did I want? What did you guys all tell me? 216 nails. So guess what I'm going to do? I'm going to multiply this by 216. I'm going to take that. I'm going to take my 0.5989 ounces times 216 nails. Gives me what? What does this represent? 100. Oh, sorry, this is wrong. So this is 129.37. I promise I'm done. So that's how many ounces what weighs. This is how many ounces what weighs. What does this represent? Yeah, this is how many ounces of nails. This is all my nails. Right? So then the last thing I have to do is just divide this by 16. So I'm just going to take that number and then divide it by 16. Some of you don't like the fact that I didn't divide the whole thing by 16, but dividing that by 16 is the same thing. So here's my answer, 129.37 ounces times 1 pound per 16 ounces equals to, notice ounces cancel. So I'm left with 8.086 pounds. Okay, I'm going to have you guys finish this part, but I just wanted to get you to this part. So now you can calculate the rest of the deck. You now know how many pounds of nails I have, right? Which over here, it tells me how much per pound. So you can kind of estimate, oh, that's like $64 in nails. Is everybody okay with that? Yeah, very good. You paid $64 in nails. So what else do you need besides the nails? What else do they need to get in besides the nails? Oh yeah, the planks. So this is where I'm going to leave you. Let me pause our video here or stop our video. Thanks for listening.